Okay. Hello everyone. Good afternoon. Welcome back. So I think yesterday we started with solving exercise questions. So tomorrow we'll continue with those problems. Yesterday I think we have solved 4 questions. Now we'll continue with question number 5 from exercise 1.1. Question number 5. So it is like list all the elements of the following sets. So there are 6 questions in this question number 5. First one, A equal to X such that X is an odd natural number. Second one, B, X such that X is an integer and the range of X is -1/2 less than X less than 9/2. Third one, C equal to X such that X is an integer and X square is less than or equal to 4. Fourth one, D equal to X such that X is a letter in the word loyal. 5, E equal to X such that X is a month of a year. Not having 31 days. And the 6th one is F equal to X such that X is a constant in the English alphabet. Which precedes K. Sorry, precedes. Which precedes K. So these are the 6 questions in question number 5. So they are very simple. Sets are given in set builder form. So we have to write these sets in roster form or tabular form. Look at this one. X such that X is an odd natural number. So can you tell me what are the odd natural numbers? 1, 3, 5, 7, so on. So in fact it is an infinite set, isn't it? It is an infinite set because they are not countable. It is not finite, isn't it? Now look at this one. B. He said x is an integer and x is a number lying between minus 1 by 2 to 9 by 2, which means that I have to collect all the integers between minus 1 by 2 to 9 by 2. Now, what is 1 by 2? 0.5. Minus 0.5 less than x less than 9 by 2 is 4.5. Now, can you tell me the integers between minus 0.5 to 4.5? 0. After minus 0.5, integer is 0, 1, 2, 3, less than 4.5, so I can take 4 also. Understood? So this set B contains the elements 0, 1, 2, 3 and 4, right? 0.5 less than 4.5. Now, third one, x is an integer, again x square less than or equal to 4. So again we have to collect all those integers which satisfies this inequality. I already told you, here this is only for x square less than or equal to 4. If this is big number, you cannot verify. So do not go for verification process. Even if the number is smaller or bigger, better you go by using baby curve method. If you remember, this is an inequality, right? So let us try to solve it like this. X square less than or equal to 4. Can I write this one as x square minus 4 less than or equal to 0? Isn't it? Now can I factorize this one as x plus 2 into x minus 2 less than or equal to 0? Isn't it? Now using baby curve method, if you remember, you have to write down the roots of this expression, that is minus 2 plus 2. And obviously the rightmost value when x is greater than 2 it will be plus. This is minus and this is plus. Alternatively you can put plus and minus because power of every linear factor is 1. Now we are looking for less than or equals to 0. Less than or equal to 0 means this region, right? Minus 2 to 2, and I can include minus 2 and 2 also because equal to 0 is there, because minus 2 and 2 are the roots of this equality, right? So in fact, what will be the solution of this inequality? Minus 2 less than or equal to x less than or equal to 2. Is it correct? Which means that now I have to collect all the integers which are lying in this interval minus 2 to 2. Now can you tell me the integers that are lying between minus 2 to 2? Since equality is there, I can include minus 2 and then minus 1, 0, 1 and 2. Understood? So this is the explanation for this question. Sorry, for this question, third question, right? Please copy. And I think these three questions you can solve on your own. They are very simple. Okay. X is a letter in the word loyal. You will just write L one time. So what will be the answer for this one? L-O-Y-A. Right? You don't have to write L again because it is repeated twice. Now you know X is a month of year not having 31 days. Isn't it? 31 days. And this one X is a constant in the English alphabet which precedes K. So you can do that, right? Preceding means before or after? Before. Okay. Precedes means the letters which comes before K. Succeeding means after K. So these are very simple things actually. Exercise 1.1 is very easy. And one more clarification, we are solving only NCERT now. After this, I will go for objective questions, okay? And we have one more question in this exercise. And after that, we will move to 1.2. Sixth question. Copied. Right. Question number 6. It is a matching question. The question is like this: match each of the set on the left in a roster form with the same set on the right described in set filter form. Fine. So I'll write down the question. 1, 2, 3, 6. First one. Please note it down. Second one, set 2, 3. Actually, left side, he has given the sets in roster form. Okay. Right side, he gave the sets in set builder form. MATHEIC. Yes. Mathematics. 1, 3, 5, 7, 9. This is like column 1. Now column 2. A. X such that X is a prime number and a divisor of 6. B. X such that X is an odd natural number less than 10. C. X such that X is natural number and divisor of 6. X such that X is a letter of the word mathematics. I hope my handwriting is legible to everyone. Okay, please let me know if handwriting is not good. Now, 1, 2, 3, 6. Now, we have to identify the appropriate option corresponding to this set. 1, 2, 3, 1, 2, 3, 6. Now, X is a prime number and a divisor of 6. What are the divisors of 6? Which are prime numbers? 2 and 3. Actually, what are the divisors of 6? 1, 2, 3, 6. But he is asking only prime number. So definitely answer to this one will be this. Correct? Next one. X is an odd natural number less than 10. 1, 3, 5, 7, 9. This was this one. X is a natural number and divisor of 6. So it is not a prime number, natural number. So I can take 1, 2, 3 as well as 6. Understood? And finally, X is a letter of the word mathematics. This one. Very easy. Please follow. Correct. Yeah. Correct. Answers are correct. C A D B. Right. Copied. Right. Fine. So before moving to exercise 1.2, I want to tell you one point, important point. You can note it down as note. So one important note before Going to exercise 1 point. It's very simple, not? First one. If B is a subset of A, if B is subset of A, then I want to find out what is A intersection B. And the second one, if A is a subset of B, then what about A intersection B? First, you tell me the answer for this one. If B is subset of A, then A intersection A is B. Correct. B is correct, isn't it? Very simple. Take the Venn diagram. It will be very easy. He is saying B is a subset of A. So B will be inside of A, right? Isn't it? This is A. This is B. This is the diagrammatic representation of B is subset of A, right? Right? Now, this is total set A. Isn't it? Now, I'll use one more color. This is B. Can you see this? Green color is B. Now he is asking what is A intersection B. What is the meaning of intersection? Common region. What is the common region to A and B? Obviously this one, which is nothing but B. So A intersection B will be B. Correct? Very simple. Now, other way, if A is subset of B, it is something like this. This is B. This is A. Isn't it? This is set B. Correct? Now this is set A. This is like A is a subset of B. Then what will be A intersection B now? What is the common region of A? The least one will be the intersection of A and B, right? Because we are taking common region for both A and B. Understood? So in this case, it will be A. Simple, right? That's it. Please turn it off. Very simple. 2 points. Okay, this is easy. Right. Exercise 1.2. First question. Which of the following are examples of the null set? Question number 1. Which of the following are examples of null set or empty set? So here there are 4 problems. First one, set of odd natural numbers divisible by 2. Second one, set of even prime numbers. Third one, x such that x is a natural number comma, x less than 5 and x greater than 7. Fourth one, y such that y is a point common to any two parallel lines. Right. So these 4 questions. Which of the following are examples of null set? Set of odd natural numbers divisible by 2. Now, do you find any natural number, odd natural number which is divisible by 2? No. Even numbers are divisible by 2, right? Odd natural numbers are not divisible by 2. So definitely this is empty set or null set. Is it correct? Set of even prime numbers. Yes, one element is there. What is that? 2. 2 is an even prime number. So this is not an empty set. Correct? X is a natural number which is less than 5 and greater than 7 simultaneously. That is, you need to take the intersection of these two. And means I already told you intersection. This phrase is important here. And or. If it is R, then the answer would have been different. Answer will be changed, right? X is a natural number which is less than 5 and greater than 7. There, you don't get any common region, right, for these two. Simple logic. If you draw the real number like this is 5, this is 7. Greater than 7 means this side towards plus infinity, isn't it? Less than 5 means towards minus infinity. Does these two lines are overlapping? No. So there is no common region for these two. So definitely this is also empty set. Isn't it? Now what about this one? Yeah, no. Point common to any two parallel lines. If you have basic idea about coordinate geometry, if you take any two parallel lines will never intersect actually. Isn't it? Two parallel lines will never intersect. So obviously they do not have any common point. Unless two lines intersect, they do not have any common point, right? So obviously y is a point common to any two parallel lines. You don't get any common point for two parallel lines. So this is also empty set. Two parallel lines. Example 3. Okay, I'll show you another illustration for question number 3. X is a natural number which is less than 5 and greater than 7. Can you tell me the natural numbers which are less than 5? 1, 2, 3, 4 and greater than 7, 8, 9, 10, so on. I said and means simultaneously. That means you need to take the common element that belongs to first set as well as second set. So do you find any common element for these two sets? No. So definitely here you will get a null set. That's why it is an empty set. Okay, just for to avoid confusion, I'll take up to 1 only. Because he's asking only natural numbers, right? Okay, I hope this is clear. Example 3. Please note it down. Thank you. Out of focus. Out of focus. Done? Right. Let's move to question number 2. This is also a very simple question. Question number 2. Which of the following sets are finite or infinite? Are infinite. First one, the set of months of a year. Very simple question. Second one, 1, 2, 3, all natural numbers. Third one, 1, 2, 3 up to 100. Fourth one, the set of positive integers. Greater than 100. The fifth one, the set of prime numbers less than 99. Answer very easy. Very simple question. Set of months of a year. It is finite. 12 months, right? So this is a finite set. What about this one? Infinite. Natural numbers. What about this one? They are countable, 100. So this is finite. Set of positive integers greater than 100. Infinite. Because greater than 100, how many positive integers will be there? 101, 102, so on. So this is also infinite. Correct? What about this one? The set of prime numbers less than 99. It will be finite. You can count. Isn't it? So it's very simple. Please note it down. Okay. Before proceeding to question number 3, let us try to look at one simple question, objective question. Copy it. Write down the question. Let Z be the set of all integers. Standard notation. Let Z be the set of all integers and set A is equals to. This is called as ordered pair. I'll speak more about this ordered pair when I start relations. Just for the timing, remember. Set of, instead of giving it as one element, he is giving set A as set of all ordered pairs A comma B such that A square plus 3B square equal to 28. And A comma B belongs to Z. And set B equal to. Again, this is set of ordered pairs A comma B such that A is greater than B and A comma B both are integers. then n of A intersection B is equal to first option 1, second option 6, third option 3, fourth option 8. Let Z be the set of all integers and A equal to AB, ordered pairs AB such that A square, that is these A and B are satisfying this relation. A square plus 3B square equals to 28 and A and B both must be integers, either positive or negative. Similarly, B is also AB where first integer is greater than the second integer. A greater than B and A and B are also integers. Now we need to find out n of A intersection B, right? Now, look at this question. First, we have to find out the set A and we have to find out set B. But here there is one thing. A contains all the ordered pairs A comma B. This is called as ordered pair. Pair means there are two. Okay. Now we have to collect A and B in such a way that those two integers satisfies this equation. A square plus 3B square equals to 28. And B is, we have to collect all those integers where the first one is greater than the second one. A greater than B. Now I have to find out the number of elements in the intersection of these two. Understood? So first thing is we have to find out the intersection of these two, then I have to count how many elements will be there in A intersection B. Now here the first thing is, let us try to analyze this one. Set A. Set A is AB such that A square plus 3B square equal to 28 and A comma B belongs to Z. Understood? Now look at this one. A square plus 3B square equal to 28. He said both A and B are integers. We will take some values randomly. And we will eliminate those values where A is less than B or A is equal to B. Because we have to collect only A greater than B. In fact, B is the subset of A. Isn't it? Okay. This equality contains all the values of A and B where A is equals to B, A is greater than B as well as A is less than B also. Understood? Now see, first, if I take A equal to plus or minus 1, I directly take plus or minus 1. Can I? Because square is there. Even if you take plus 1 or minus 1, A square will be plus 1 only. Isn't it? Now if I take A as plus or minus 1, either you can take A or B. Doesn't matter. Understood? Here I am doing like, if I take A, I will get B value. If you take A, correspondingly you will get A value. So this is 1 plus 3B square equal to 28. Now from this one, 3B square equal to 27. Now B square equal to 9. So B equal to plus or minus 3. Isn't it? Now from here, if I take A equal to plus or minus 1, I am getting B as plus or minus 3. Isn't it? That is, corresponding to these two, I will get these possibilities 1, 3 or 1 minus 3, minus 1, 3, minus 1, minus 3. These possibilities I get. Is it correct? 1 comma 3, 1 comma minus 3, minus 1 comma 3, minus 1 comma minus 3. But I said we have to take, because we are taking intersection, right? So for example, if you are taking this one, it should belong to B also. Then only it will belong to A intersection B. What is the meaning of intersection? Which belongs to both A as well as B. But obviously this is not correct. Isn't it? 1 greater than 3, it is wrong. Because we have to take A greater than B. First number should be greater than the second one in this ordered pair. What about 1 minus 3? I can take. Are you following it? Minus 1 comma 3. Wrong. Minus 1 minus 3. Yes. Minus 1 is greater than minus 3. Isn't it? Minus 1 is less negative than minus 3. Okay. So 1 comma minus 3 minus 1 comma minus 3. Now similarly, let me try with 0 also. Because I can take 0 also, right? Isn't it? If I take 0, 3b square will be equal to 28. B square equal to 28 by 3. First of all, is it possible? No. Why? 28 by 3 is not an integer. But b is an integer, right? So definitely b square is also integer. So according to the given condition, b square equal to 28 by 3 is not possible reason since b belongs to z. If b belongs to z, b square also belongs to z. But here we are getting b square as non-integer. Understood? So definitely, if a equals to 0, we are not getting any possibilities. Are you getting it? No. If you take a equal to plus or minus 2, what will be this one? 4 plus or minus 2 whole square. 4 plus 3b square equal to 28. Now 3b square equal to 24. B square equal to 8. Now if b square equal to 8, what is the b value? Plus or minus root 8. What is root 8? 2 root 2. Is it correct? Root 8 is 2 root 2. Again 2 root 2 is not an integer. So this is also not possible. You understand? Now similarly, if I take a equal to plus or minus 3, what will you get? 9 plus 3b square equal to 28. 3b square equal to 28 minus 9, 19. Now again, b square equal to 19 by 3. This is also not an integer, so this is also not possible. Correct? Let us try another value. If a equal to plus or minus 4, okay, it will be 16 plus 3b square equal to 28. Now 3b square equal to 28 minus 16, 12. Now b square equal to 3 4 0. So definitely b equal to plus or minus 2. It is possible. Now can you tell me what will be the combinations you will get here? 4 comma 2, 4 comma minus 2, minus 4 comma 2, minus 4 comma minus 2. But I need to take only a greater than b. Isn't it? You have to consider b also because we are finding a intersection. Understood? A greater than b. I can take this one. This one also I can take. This one, a greater than b. This is wrong. What about this one? Wrong. Because minus 4 is not greater than minus 2. Minus 4 is less than minus 2. Is it correct? So here also we got two possibilities. And here also we got two possibilities. Now let us try to verify a equal to plus or minus 5 also. I'll write it here. If a equal to plus or minus 5, what will you get? 25 plus 3b square equal to 28. 3b square equal to 28 minus 25, 3. That is b square equal to 1. b equal to plus or minus 1. Understood? Now again, what combinations you'll get here? 5 comma 1, 5 comma minus 1, minus 5 comma 1, minus 5 comma minus 1. Again, I have to collect only those ordered pairs where a is greater than b. This is okay. This is also okay. But this is not okay. This is also not okay. Isn't it? In these two cases only you will get a greater than b. Now, what about a equal plus or minus 6? There is no space. First copy this. I will conclude. Since this is the first problem, I am explaining very slowly. Okay. But you can do it if you solve 2 to 3 questions. It will be easy. So again, I'll explain. He gave this question. A has ordered pairs a comma b such that a square plus 3b square equal to 28. Okay. Now, where a belongs to z. And he gave b as ordered pair a comma b where a greater than b. Now we need to find A intersection B. So can I rephrase the question something like this? Now I have to find out those ordered pairs A comma B which satisfies this equality as well as A greater than B. Understood my point? I have to find out all the possibilities of A comma B. At the same time, they must satisfy this condition A greater than B. Then you will get the A intersection B. Intersection means both sides simultaneously. Intersection means simultaneously, remember. Okay, that is the meaning of that. So that's what I'm doing. AB are satisfying this equality as well as A is greater than B also. Okay. Can I raise the question? Can I? I'll conclude. Finally, if I take A equal to plus or minus 6, what will you get? 36 plus 3b square equal to 28. Now from here, 3b square equal to how much? Minus 16, right? Is it correct? Yeah, minus 16. No, minus 18, sorry. Minus 18. Is it correct? Yeah, minus 18. Now, 3b square equal to minus 18. What about b square? Minus 6. Can b square will be equal to minus 6? No. B square is always greater than or equal to 0, right? Isn't it? Square of any number is always positive. So b square equal to minus 6 is also not possible. Now logically, if this is not possible for a equal to plus or minus 6, even if you take the values of a greater than 6, it will not be possible. So here we have to stop. Understood? When I take a plus or minus 6, I am getting b square as minus 6. Isn't it? That means, actually it is only minus 8. 28 minus 36. Isn't it? 28 minus 36 is minus 8. So b square equal to minus 8 by 3. It's okay. But anyway, you will get negative value. B square equal to minus 8 by 3. First thing, it is negative number. So b square cannot be negative. And it is not an integer. Negative rational number we are getting. Isn't it? So logically, if it is not possible for a equal to plus or minus 6, it will not be possible for plus or minus 7, plus or minus 8, all those values. So we can stop here. Understood? This is where we have to stop. So finally, therefore, in A intersection B, how many elements we are getting? Start with 1, 3. So instead of giving elements, we give ordered pairs. Next one, minus 1, minus 3. And then 4, 2. 4, minus 2. 5, 1. 5, minus 1. Apart from this, do you get any other elements? No. Which satisfies this equation as well as A greater than B. So what he is asking actually? Cardinal number of A intersection B. So how many ordered pairs you can see? 1, 2, 3, 4, 5, 6. So answer will be 6. Understood? 5, okay, fine. This one. 1, minus 3, sorry, yeah. Minus 1, minus 3, 4, 2, 4, minus 2, 5, 1, 5, minus 1. So totally you can see 6 ordered pairs. So n of intersection will be equal to 6. Please note it down. I hope this question is clear. Okay, before I close, I'll just give you one question to try it as homework.
Ask the students to 8 to 11 11 to 1
Classes. అందులో పోల్ పెడుతున్నాను సార్. Okay, one small announcement.
Evening 2 to 6.
Okay. So you want to have classes from 8 to 11 in the morning or
11:50 to 1.
11:15
to 10:50 to 1:50.
or 10:50 to 1:50. So we have two slots.
Slot will be better.
Slot 1, 8 a.m. to 10:50 a.m. Slot 2, 10:50 to 1:20 p.m. So currently we are having classes in slot 2. So you please send us your opinion whether you want to have classes in slot 1 or slot 2. Evening classes are fixed 4 to 6. There won't be any change in evening slot, but for the morning classes,
Simply slot 1 or slot 2.
just send your opinion as slot 1 or slot 2. You don't have to mention the timings. Okay, slot 1 or slot 2. So you try this question and tomorrow we'll discuss. Okay, thank you.
DD channels classes when they are English medium, 9 to 11